The details of that 9.9 out of 10 remote code execution vulnerability that we found out about yesterday has been revealed much sooner than anticipated because there was a leak out of Vince. I'm going to get to all of that in a minute, but first let's talk about exactly what this vulnerability is. High level, yes, it is a massive vulnerability, and it does allow people to execute code on remote machines, not just Linux, without authentication by simply sending a UDP packet. By sending a UDP packet to the remote machine, you can then execute code, arbitrary code. This is very, very much a very bad thing. I absolutely would rank this a 9.9 out of 10. This is not good at all. The researcher that found this, Simon Margaritelli, has published all of the details. Wasn't going to have this information published until October, I believe it is 5th, but because it was leaking out there anyway, it was more reasonable to get it out there. And I agree with Simon Margaritelli's reasoning for why he published this information now. If it's already leaked out and potential bad actors have access to this anyway, why not get this information widespread so that people can at least mitigate against the possible problems? Now, the core of the system here is entirely around the printing subsystem. It's around cups, the common Unix printing system, baby, that almost every Linux machine has. I'm going to read a couple of quotes here from Simon's post. This is over at evilsocket.net, which is his website. Hello, friends. This is the first of two, possibly three, if and when I have the time to finish this Windows research write-ups. We will start with targeting GNU Linux systems with a remote code execution exploit. As someone who's directly involved in the CUPS project set, and again, CUPS is responsible for printing. It's used on Linux systems. It's used on Chrome OS. Even Apple's systems have variations on CUPS. I don't know if their specific versions are impacted with this, but they have them as well. Quote, from a generic security point of view, a whole Linux system is, as it is nowadays, is just an endless and hopeless mess of security holes waiting to be exploited. We all know this. Extraordinarily complex and interconnected systems breed an almost endless number of possible access points for any sort of exploit. That's just how it is with the increasingly complex systems. So the specific vulnerabilities that are being listed here today, there are 4 of them. Issues in cups browse D, lib cups filters, lib pppd, and cups dash filters. He's got the CVE numbers here published for all of them. However, those CVEs are not yet made public, but you can grab them, copy them, and search for them. And as soon as they get made public, additional information will be available on them. But again, this is all around the printing system, specifically as it relates to network printing, right? Network printing, which means it impacts a lot of systems. Just to give you an example here, both Ubuntu and Fedora and many other extremely popular Linux distributions ship with cups browse D on and enabled by default. So when we're talking about Linux desktop systems, and honestly, even most Linux server systems, you're going to be wanting to check to see if you've got that on by default. It's a lot of systems. So the entry points for this particular attack. The first is that if you are on the public internet, just on the internet or on a wide area network, a remote attacker sends a UDP packet to port 631. No authentication whatsoever is required on that. That's an entry point. Again, a UDP packet. A UDP packet. That is... Holy heavens, more details on how that works. Or if you're on a local area network, a local attacker can spoof zeroconf and achieve the same code path leading to a remote code execution. So it's incredibly simple to accomplish this. Quoting one of the first comments from the guy who literally wrote the book about cups while trying to explain to me why this is not that bad. This is crazy. Quote, I am just pointing out that the public internet attack is limited to servers that are directly connected to the internet. The picture that Simon Margardelli included here was brilliant because, yeah, again, I'm going to repeat that. This is a reason why this attack is not that bad. The public internet attack is limited to servers that are directly connected to the internet. That's like saying the issue with the cars driving on the road is only limited to the cars driving on the road. It's like, okay, let's go ahead and rewind and reread that yourself. So he lists here some affected systems. So cups browsed are packaged for most Unix systems, he says. So most GNU Linux distribution, yes, that's true. Some BSDs, also true. Chromium and Chrome OS, also true. Solaris, yes. He says possibly more, and the answer is yes to that. This is going to impact a lot of systems. He goes on to say this thing is packaged for anything, and in some cases it's enabled by default. In others, it's not. Go figure. It is more often than not enabled by default. It's not enabled by default in every system, and there are ways to button down this, which we'll get into as we go along. But assume that cups browsed is enabled by default on your system. So check this out. I've been scanning, this is what he said, the entire public internet IPv4 ranges several times a day for weeks, sending the UDP packet and logging whatever connected back. And I've gotten back connections from hundreds of thousands of devices with peaks of 200 to 300 concurrent devices. This file, he published a file, contains a list of the unique Linux systems affected, all the different specific Linux version numbers, kernel numbers, and whatnot. Note that everything that is not Linux has been filtered out. And if you go check out the file on his website, it literally is just a list of all Linux kernel versions. Right? It's just everything. And the reason he knows that is because the response you get back by sending that UDP packet actually tells you what kind of system you're running. So you just send this UDP packet and you get back the kernel version that you're pinging, basically. It's crazy how much information you can get. So remediation. So ways you can work around this. First, disable and remove cups browsed service if you don't need it, and probably you don't. It's only necessary if you're printing, right? And if you've got a network attached printer. Update the cups package on your systems, and in case your system can't be updated for some reason, and for some reason you rely on the service, block all traffic to UDP port 631 and possibly all DNS-SD traffic. Good luck if you use zeroconf. Okay. He also says his personal recommendation, I've seen and attacked enough of this code base to remove any cup service binary and library from any of my systems and never again use a Unix system to print. Oh man. I'm also removing every zeroconf Avahi bonjour listener. You might consider doing the same. All right, I'm going to skip through. I'm not going to read his whole story here, but I want to point out a couple of things that he found along the way so you understand exactly how much power this particular remote code execution exploit can have. So he noticed this cups browsed was running. He noticed that process was running as root and listening to you on UDP port 631. He says that after some Googling, I found out that cups browsed is indeed part of the cups system and is responsible for discovering new printers and automatically adding them to the system, right? So that's what cups browsed does. All right, let's just jump ahead a little bit because he goes through the technical details. If you want those technical details, go grab it. If all checks pass, so if you send in that UDP packet and you start communication, if all checks pass, which they're probably gonna, 2 text fields parsed from the packet are passed to the found cups printer function, right? Then it goes through a series of various functions as it goes along, and then we get to here. Both of these issues, he gets through a number of issues that he hits. Issues have been reported and thoroughly documented to the devs and the CERT, but nobody seems to give a damn. I can tell you that there are other more easily exploitable code paths going on, not just the functions he outlines, not just in the discovery mechanism, also reported and ignored. To this day, they have not been acknowledged or patched. Happy hunting. So Simon Margaritelli, he definitely has some strong feelings about how this has been handled right out of the bat. He feels like this hasn't been taken seriously enough, and looking at things initially, not seeing some of the sort of secret communications that have happened and have not been opened up, it does seem like, yeah, maybe this hasn't been taken as seriously as it should. He continues, quote, "So I tell myself, there's no freaking way that if I send this packet to a public IP address running cups, that computer will connect back to the server I specified. No way." And he, holy beep, not only it connected back immediately, but it also reported the exact kernel version and architecture in the user agent header. It also reports the requesting username on the target for some of the requests that you can send in. Again, via plain old UDP, baby. He says, I went back to writing some code, and by using the IPP server Python package, I was now able to respond properly with attributes I controlled to the service request. My fake printer was immediately added to the local printers with no notification whatsoever to the user. Then he posted a screenshot of him creating a new printer called God with the location of in your butt, which is clearly a real printer. And that's very, very crazy, right? That you can do that without any authentication from the end user. The end user doesn't get to choose it. You just send some packets at a machine unauthenticated, and you can add printers to that machine. And he goes on to say, it looks like the service fetches these attributes when it creates some sort of temporary file. The attributes he was pointing out that were created, a PPD file on which these attributes are possibly saved. So he's like, okay, so I can send some attributes for a printer it's added into a PPD file that's saved locally on the user's machine. All right, so what exactly is a PPD file? Well, this is commonly not known. I used to work at Hewlett-Packard like in the 90s. I worked at Hewlett-Packard, and I'm pretty intimately aware with this, but he writes a pretty decent description of exactly what a PPD is. A PPD file is a text file provided by a vendor that describes in a domain-specific language the printer capabilities to cups and instructs it on how to use it properly. It's basically here's this printer, here's the details about it, here's how you use it. It's a real simple file that way, right? I spent a few hours just reading the PPD specs and studying cup specific extensions in order to find something I could really try to perform an attack. And then I found out about cups filter to directive. Okay, here's where the remote code execution from all of this comes in, because up until now, you're just sending UDP packets and being annoying because you're creating a printer that's fake on someone's machine. That's annoying, but that's not 9.9 severity, right? Here's where it gets gnarly. A filter is any executable contained in the user lib cups filter path, which will get executed when a print job is sent to the printer. And I think several of you are going, I see where this is going. Now, it uses something called Fumatic. And, quote, they have to allow Fumatic, the command line program, to accept pretty much anything, including Perl, or many printers will stop working on Unix. Basically, there's this old chunk of code that's there to handle, called Fumatic, all of these different printing scenarios and different types of printer hardware, especially older printers. Newer ones, not quite as often. And you have to basically allow it to execute darn near anything in order for it to happen. So, in theory, be using that we should now be able to, and this was him theorizing about what he could do before he tested it, force the target machine to connect back to our malicious IPP server, return an IPP attribute string that will inject controlled PPD directives to the temporary file. Basically, send some UDP packets, make a connection, send some attributes, just some custom created malicious attributes that will be created into a PPD text file on the target's machine, and wait for a print job to be sent to that fake printer for the PPD directives, and therefore run the command, right? Kicks off the command, and you can kick off that printer the same way. So let's see how this plays out. Well, it worked. It worked. He tried it. It worked. He provided the details here on how you can do it. So if any of you are looking to do it, it wouldn't take too much work to create the empty things that he didn't mention in here. He says one additional thing he included here, and this is about how this is all played out since he revealed this to the printing group, right? So this is the printer developers. While the research only took a couple of days, this part, talking with the developers of the projects, took 22. And this part was not fun. I will only say that, to my personal experience, the responsible disclosure process is broken, that a lot is expected and taken for granted from the security researchers by triagers that believe like you have to prove to be worth listening to, while in reality they barely care to process and understand what you are saying, only to realize you were right all along 3 weeks later, if at all. 2 days for the research, 249 lines of text for the fully working exploit, 22 days of arguments, condescension, several gaslighting attempts, more or less subtle personal attacks, dozens of emails and messages, more than 100 pages of text in total, hours and hours and hours, and woo, lots of swear words there. He's feeling salty about it, is what I'm saying. And the 9.9 rating. He goes on to show some screenshots how the 9.9 rating was actually given by engineers at Red Hat, who rated it as such. And I'm going to be honest, this is pretty. I agree that this should have a very high rating. I don't care if you call it a 10. I don't care if you call it a 9, a 9 point something, whatever. This is not like some middle of the road 5 point something exploit. You have the ability to remote code execute as root, because that's what cups browse d run as. It runs as root. You have the ability to run as root an arbitrary code execution to any system, mostly via just some simple UDP. It's too trivial. It's too trivial, and it's too widespread. Now, there's a lot of machines that don't currently have cups browse d enabled by default, and that's probably good. If you haven't blocked, let's go back up here a little ways about what you can do to block this. If you have not blocked, was it port 632? I'm going to go look it up for you real quick. Port 631. Port 631, block it. Block it now, because it's yeah. This is too easy to exploit. And now that this is out in the wild, which this Simone Margaritelli, he's not really the one that put it out in the wild. It was leaked out there. Now here's where things get a little weird. This was leaked over on breachforums.st. I'm not going to show it here, but if you go log into there, you can get into it. And it looks like, because of the information that was leaked, it was specifically information that Simone Margaritelli had given to Vince. Now, what is Vince? Vince is the Vulnerability Information and Coordination Environment over at Carnegie Mellon at CERT. And that means, and they're really the ones who handle all of this stuff, right? All right. All of this, all of the, hold on, let me scroll down here so you can see here, all these CVEs and whatnot, you'll go find those over with certain Vince. And there was a leak within Vince. So someone at Vince if Simone Margaritelli is to be believed, which so far he's proven he's followed through. I mean, he's claimed everything he claimed previously has proven to be true. Then Vince does have a leak. The other possibility is that Simone Margaritelli is the leak. Those are kind of the two obvious options, or someone else was given this that we're not hearing about. But either way, there clearly was a leak in all of this that is worth looking into. So once this was already leaked out there, it's good that we now have the details around it. And we know to disable cups. Get rid of cups D, cups browse D, disable it completely, uninstall it from your system if you don't use printers, block port 631, just all sorts of things that you can do to mediate against this potential attack. However, as Simon Margaritelli pointed out, this is pretty widespread. I mean, having Cups Browse D enabled by default on an open port is incredibly common. He found hundreds of thousands of examples, and I have no reason to doubt that. Just simply knowing how these printers work and knowing how networking works and knowing these distributions as intimately as I do, I can say, yeah, Ubuntu has it by default. Fedora has it by default. So many distributions have Cups Browse D on by default for convenience. You want to make printers work well out of the box for end users, otherwise they're going to start complaining. So it's on by default. I mean, that's how you discover and add printers. It's like, oh, there's a network printer on your thing. Here, it's added for you, so you can now print with it. Right? So there you go. So is this a 9.9? I would say so. You're probably over the coming days going to hear a lot of argument about the severity ratings of this one, about whether or not certain distros are vulnerable at all, how overblown it might have been or under discussed it might have been. I think you're going to hear a lot of yelling from both sides on that. But regardless, this is a pretty major issue, and it's going to be difficult to fix this issue fully. And the reasons for that are the ability to do the code execution with inside of the cup system is a critical component of using hundreds and hundreds of models of printers. And so in order to fix this fully, that needs to be patched, and that's going to break the Linux compatibility with a lot of printers unless a new system is put in place and new ways of working with those printers is developed, which is going to just be an absolute massive amount of work. I mean, considering this code has been around for decades now and is a giant spider web. It is not an easy code base to understand. The individual printer drivers, such as they are a funky mismatch of executable files, Perl scripts, all sorts of things in order to format files correctly when they're sent to the printers. So fixing them for all of these printers is going to be a mild nightmare. And I'm sure that the cups and the open printing developers and whatnot have been hesitant to do that because it is a nightmare. It's not a mild thing. It's a complete re-architecture in some ways of how a lot of these systems work. So going forward in the very near future, my guess is we're going to see printing support on Linux hindered significantly in the name of securing our systems. I mean, that seems like the reasonable way to go. We can't leave all these vulnerabilities in place, and we can't simply expect that everyone on a device is going to be behind a firewall blocking port 631. It's a good temporary measure, but really this needs to be tackled with inside cups. So there you go. There you have it. There's all the details. Again, you can read all the details posted over at Evil Socket, which is a great domain.net. So thank you to Simon Margaritelli for posting all of that and letting us know what to do to lock our systems down. And with that, ladies and gentlemen, boys and girls, nerds and nerdettes across the inner tubes, I do declare, end broadcast.